Okay, so this is part 2 of our Unit 3B regressions lesson. All right, so we're looking at taking data, modeling that data with a linear, a quadratic, or an exponential regression equation. All right, we're going to use that equation that we find, you know, like the line of best fit, the parabola of best fit, the exponential curve of best fit. We're going to take that line, curve, whatever, of best fit, and we're going to use a prediction. We're going to use that to be able to make a prediction about the future, answer questions about data values that we don't actually have. All right? So we'll discuss that as we get into the next problem. So this is going to be example 2. This is part 2 of Unit 3B. Now, let me go ahead and say that the first part of this, the very first problem, the first time you do this, it takes a while. So that last lesson, 30 to 45 minutes long. This one will go much faster. This will go much faster. You'll still run into errors and problems occasionally as you do these problems. Once again, I'll try to get a lesson uploaded that deals with common errors, common difficulties in your calculator as you do regressions. So without further ado, we'll get into this. To remind you, our steps are here. We will display, we'll make sure R displays on our calculator by these steps. Once you do that, you'll never have to do it again unless you reset your calculator. All right? So our main first step in every single problem will be to enter the data. Once we enter the data, we will study the models. We'll do that for the linear, the quadratic, and the exponential. We'll have 3 models to deal with. Our goal will be to write down the R value. This is the key. We want to write down the R value, the correlation coefficient. Once we write down the R value for each of the 3 models, linear, quadratic, and exponential, then we can make a scientific decision, or somewhat of a scientific decision, not based on our opinion, not based on kind of what looks like it might be the best line, the line of best fit, but actually something that's built on empirical evidence. Okay? So after we study the models and we write down our R values to 4 decimal places, then our next set of directions will be to select the best model. Okay, so we're going to use the R value to do that. And remember, the R value closest to 1, actually the absolute value of R, of each of those 3 R's, that's closest to 1, number 1 wins. Okay? So it might be a negative R value, it might be positive, whichever one is, when you check the absolute value of it, which one is closest to 1 wins. So then, after we do that, we got to answer questions and make predictions. Most of the questions are built on 2 possibilities. I give you an X value, you find Y, or I give you a Y value and you find X. So those steps are all right there for you. All right, so now it's time to look at the problem. Okay, so we're going to start off by entering the data. So we turn our calculator on. Whatever might be there, we can hit clear and clear it out. Now let's go to stat. And please follow along with me very closely. I pressed stat. I select edit by hitting enter. Make sure you're doing this. Now, so I've got list 1 and list 2. I've got stuff already in here from the last problem, from the last situation. Here's what I do, and I didn't do this in front of you, with you for the last problem, I don't think. So I want to clarify it right now. In order to start a brand new problem, the best way to begin is to make sure you have list 1, list 2. If you don't have list 1, list 2, raise your hand if that's anybody here. Okay, if you don't have that there's a quick fix for that. I'm going to save that for the common errors video. We'll deal with that later. Right now, I'm just going to arrow up, select list 1. I'm going to hit the clear button. Clear. Nothing happened. But when I arrow down, then that list clears out. Same thing for list 2. I come over to list 2, go up, I hit clear, I arrow down, it clears out. So now I'm starting from scratch, list 1, list 2. And then the point of this problem is to kind of show you the sorts of problems that you run into when you're dealing with exponential regressions. You can see here, we're going to be doing an exponential regression, but let's just begin. List 1, enter in the years. List 2, enter in the cell phone subscribers. So at this point, I'm going to pause the recording and let everyone take a moment to enter that data in. Okay, I'm back. I have entered my data. It's always in your best interest to just give that data just one quick look. Did we enter everything in correctly? If you start off with wrong data, one digit in any one of these values is off, then it's all going to be messed up. All right, like everything you do from this point forth is going to be messed up. All right. So just checking these numbers: 19.3, 13.1, 8.9, 6.4, 4.4, 2.7, 1.6. Everything looks good to me. So now I move on to step 2. All right, step 2 is to study the models: the linear model, the quadratic model, the exponential model. Okay, like think of the models this way. If you have some sort of clothing that you want to model, you could have 3 different humans wear those clothes. They could all 3 model the same piece of clothing. Okay? Depending on the person, each one will, perhaps one may look better than the others. All right? Our goal here is to do the same thing. We're going to try on the linear model, we're going to try on the quadratic and also the exponential, and figure out which one looks the best based on the R value. All right? So here we go. I'm going to hit Stat. Arrow over to Calc. Come down to where it says Linear Regression. That's number 4. Now there's another linear regression. If you move on down, you don't want it. We want this one that's AX plus B. That's MX plus B. Slope-intercept form. So we're going to select linear regression. I hit enter. Freeze for just a moment. I'm reminded that this problem is set up a slightly different way than the rest of the problems. This one specifically tells me to run the exponential regression. And so I was starting to go about this the same way the rest of the practice problems are that I have here for you, including the last example. Let me follow these directions specifically as they're given to us. We're going to run the exponential model. So forget the linear regression this time. Forget the other models. Forget linear model. Forget quadratic model. Let's just look at the exponential model. So clear this out. Stat, Calc. I'm going to come down to number 0, actually. The 10th option, number 0. Exponential regression. Okay, so I've done that. And then I'm going to follow my directions from the previous pages, the notes. Remember, right here it tells us what we're going to type in. We're going to type in in this case, exponential regression, L1, comma, L2, comma, and Y1. To find those, I would refer you to the previous lesson, or you can just kind of follow along here with me. In order to find L1, I'm going to press second and then the 1 button. The comma is above the 7. Second and the 2 button gets me list 2. Hit the comma. And then I'm going to press the vars button, which is right here diagonally below the arrows. Vars. Over to get the Y vars. I'm going to hit enter to select function and enter to select Y1. This is what it should look like if you're on a TI-83, TI-83 Plus. If you're on the TI-84, then you have that separate menu. X list is list 1, Y list is list 2, and you store the regression equation to Y1. Okay, does everybody have that that's doing it here? Does everybody have that okay? Anybody need me to look at their calculator? Okay, then we're gonna press enter and watch what happens. Error, overflow. So this is a not so common error for us to run into. Like I said, I'm gonna have a video separate for common errors, but this is not so common. Instead, this happens in very specific situation. Okay, so why do we get this overflow error? Notice the question that I ask you. When you use the given years, it causes what error? So the years cause the error. Why? I'm going to answer this. Exponential functions, what do? They grow slowly and then they grow really quickly. Right? And so like if you have the equation y equals 2 raised to the x, if this input is large, if the x value that you're entering in, such as 1998, that's 1,988, and that is a very large number when you take 2 and you raise to that power. What is 2 raised to the 1988? Excuse me. Well, that's 2 times 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 2 1,988 times. You got 1,988 factors of the number 2. Now, 2, 4, 8, 16, 32, 64, you know, those don't seem like large numbers. But when you start doubling, when you keep doubling like that, it gets obnoxiously large. And we, by the way, may not even talk about, in this particular problem, we may not even be talking about the number 2 as being our base. It could be the number 5 or 7 or something like that. So it could be 1,000. I mean, it could be much larger than 2. So the point being is that this is such a large number that it's too big of a number for your calculator. It forces scientific notation in some sense. Yes, ma'am. Okay, so how do we answer this question? We'll just say large inputs cause extremely large outputs. And in parentheses, I'll write too big for the calculator. Okay, so the question here is, what happens when you change the years to 2-digit years? Here's what we have to do. We have to go back to stat, edit, stat, oops. So I can, let's see what happens if I click go to. Okay, that doesn't actually take me to where I actually solved this problem. Where I solved the problem is to press stat, edit. I'm going to come over here to list 1 and change that from, you got some options here. It's kind of tricky. You could do, you know what, I'm looking at what I entered in. I entered in 1998 at the beginning. Now, that's what I did. That was a mistake. I meant to, in the very beginning, enter in 1988. Now, either way, I still would have gotten that error. So that was just a goofy mistake that I made. But, and that's what I was saying, you got to go back and just make sure your numbers are entered in correctly. I didn't check my dates like I should have. So, change this to 88. The next one to 89, 90, 91, 92, 93, and so forth. Now let me ask you something before we go any further. What would happen if I wanted to make some prediction about years, let's say in the year 2000? What would I be entering in for the year 2000?
Or 100.
So I would go 98, 99, 0. Yeah, I should enter in 100, right? So keep in mind, I'm not just entering in the last 2 digits, but I'm starting at 88 and I'm working through. 2000 would be the year 100. 2001 would be the year 101. 2002 would be, I didn't mean to say 101, I meant to say 00. No, I meant to say 101. And 2002 would be 102. And so forth. It's a little confusing, but you know what I mean. So here we go. We changed it to 2. We changed the digits to 2 years. Let's go. We changed the years to 2-digit years. And now we're going to go back to stat. Actually, you can just hit quit. Do you have this showing on your calculator? So it's already there. We don't have to go back through the effort of hitting exponential regression, L1, L2, Y1. We don't have to do that. It's already here. So now, let's try it. I'm going to press enter. It took a minute for the calculator to process it, but here it is. So it gives me a new equation. Let's just go ahead and write down y equals, let's write down this equation. This is a times b raised to the x. A value is 7.14. The b value is 1.4. U3B2-4 if we round it to the hundredths place. And that's going to be raised to what power?
X.
The x power. Okay, so this is our equation. Here's the bottom line. It works. Why? Because the inputs are smaller or small enough. It works because the inputs are small enough. Now, so what would you do to get an accurate answer? I'm not even sure what the question here even means. But let's go down here to the bottom. Let's answer this question. According to this model, the number of cell phone subscribers in 2011 is 11,171 million. In other words, over 11 trillion. Is this a realistic estimate? Why or why not? Does this make your model wrong? That seems to indicate maybe it's not. I want you to think about this question for a moment. I'm going to pause the recording and let you kind of ponder the question, and we'll come back. Okay, so I took a moment and I tried to answer this question.
I have a statement.
Okay, what's your statement?
Why would you even use an exponential growth graph on this if it's not between these certain amount of years? Because if you keep going, I mean, the exponential thing is just going to keep right. Why would you still use it?
Okay, so the question that's been posed is, why would we use an exponential model
After a certain amount, because
after a certain amount of years? Okay, so that's an excellent question. So in a way, populations grow exponentially. But that's not totally true. Populations start off growing very slowly, and then as more and more and more people are born, it begins to grow faster and faster and faster. You know, but the thing about it is, most populations in most societies actually begin to level off for whatever reason. If you take some sort of biological example, just in nature, what happens if too many of a particular animal are born and they kind of take over a particular region? What happens?
They're going to eat all the food and they're going to starve.
They often eat all the food, then they begin to starve and die off, or they move elsewhere, right? So what happens is they end up hitting kind of a level where they can't grow any further. They've outgrown the region that they're living in, and so it levels off. So this model is actually called logistic model. We're not really focusing on the logistic model in this class. We're focused on linear, quadratic, and exponential. But know that populations, for our purposes, typically are represented by exponential models. However, in real life, it's more like logistic models. So a logistic model grows slowly, then it grows really quickly, and then it levels off and kind of grows slowly, or just, kind of grows slowly again. All right? Anyway, let's go ahead and finish this question. So here's how we answer this model, this question. according to the model, the number of cell phone subscribers in 2011 is 11,171 million. That is over 11 trillion. Is this realistic? And the answer is no. Since on February 1st, (2017), we Google the current world population, and we see that it is about 7.4 trillion. All right, 7.4 trillion. So let's go, assuming that's correct, let's go to back here. Okay, this would include babies, this would include elderly people, this would include people in societies that have zero technology, I would assume. I'm not sure about that. But this is an estimate, obviously. Question?
Billion or trillion?
Was it? Shoot. It was billion, right? Billion. Either way, it's less than the prediction here. It's less than that. So, is this realistic? No, it's not. Thank you for that clarification. According to which website was that? It was worldometers.info. May not be the most accurate, probably is accurate enough. It's more accurate than I would guess on my own. So, either way, it's probably true within a billion or two. And so, why or why not? We answered that. And does it make the model wrong?
No.
Okay. The model is it wrong or is it right?
It's not wrong. I wouldn't say it's right for the situation.
Okay, I'm interested in your answer. I mean, because I agree with you, but I want to get more clarification on this from anybody that wants to respond. Is the model right or is it wrong? Is this model right here, the exponential model, 7.4 times 1.46 raised to the x, is that model a bad choice to represent the data? What do you think?
It's possibly correct till a certain point that it just would make no sense. In 2011 you'd be 7 or 11 trillion people, but that's kind of impossible in the population.
Okay, so I love that answer. Okay, it kind of hit it on the spot. The model is correct up to a certain point. We'll say up to a certain year. It's not our responsibility necessarily to say right now what year should we stop using the model. So we're not going to respond beyond that. However, I'm just going to quickly show you the way this looks on the calculator graphically. If I turn the calculator on and I hit graph, now wait. Don't hit graph a bunch of times. Don't hit any other buttons. Just wait. Okay, nothing showed up. Why is that? It's because all the data is in one place and we're looking somewhere else right now. So we're going to hit zoom and then arrow down to where it says zoom stat. So it's going, the calculator will zoom in on the statistics location. All right? So there it is. The dots are the actual data values that we have recorded. And look at that. Our curve goes through all of them, or really close to all of them, perfectly, except for maybe that last one. Let's, here's something that I'm going to try. I'm going to hit zoom, and I'm going to zoom out a little bit. So I press zoom out. Okay, so here's the thing. Obviously, right here at the year 1997, I'm thinking that may be this curve worked really well up through 1997 or maybe 1996, but I think at this point the curve is just taking off too quickly. Our population is growing much more slowly than that. The population probably does something more like this over the next couple years. And so it really the curve itself, the model separates itself from reality. And so to use it past 1997 would be a very unwise choice.
You did zooming out?
Yeah, after I hit zoom stat,
Yeah.
and then I hit zoom out, and this is what I got.
Mine didn't do that.
Okay, so I'm going to kind of stop this video at this point, and we'll do some more problems, some more examples in the next lesson. So this was not the typical sort of question. This was a variation dealing with a very real situation where you have large inputs and you need to use an exponential regression. Okay? How do we deal with the large inputs? What do?
Make the number smaller.
We make the input values smaller. Okay? So our way was to change the years from 1988 just to 88. That is a good way of doing it. There's other ways of doing it. For instance, you could make 88 become year 1, and 89 be year 2, year 3, year 4, and type in 1, 2, 3, 4 instead of 88, 89. So there's different ways of handling this, and just depending on the situation, that will be the deciding factor. So anyway, thank you for watching the video, and we'll move on to the next lesson.